Forget chatbots and image generators for just a second. We're diving right into this explainer because the real AI explosion of 2026 is happening right out here in the physical world. We're talking about a massive convergence of hyper-fast silicon and autonomous hardware. And to see exactly where this is heading, let's start with a breakthrough that literally redefines the limits of machine speed, a robot that plays ping pong. So, think about the sheer physics involved here. We know AI can write an essay, sure, but can a machine actually react fast enough to defeat a professional human athlete under official rules? It's an entirely different universe of computation to physically track a moving object, predict its exact trajectory, and then swing a mechanical arm to counter it, all in fractions of a second. Well, to answer that, we just need to consider one number, 9,000. That's the RPM, revolutions per minute, spin tracking capability of Sony AI's groundbreaking Project ACE. This is a fully autonomous table tennis robot. It isn't just tracking where a ball is. Its perception system is actually reading the microscopic spin on a tiny, lightweight sphere flying across the table at breakneck speeds. It's absolutely wild how it bridges the gap between digital thought and physical action. Project ACE doesn't rely on hard-coded if-then rules. Instead, it uses advanced reinforcement learning. It basically operates on a lightning-fast loop. Sense, decide, act. It senses that 9,000 RPM spin, decides on the absolute optimal counterstrike, and acts with mechanical precision in mere milliseconds. It's fast enough to legitimately defeat human experts, and it does it playing strictly under official international rules. It's a massive milestone. It proves that physical AI is now moving faster than human reflexes. Section 1. The hardware powering AI. The silicon foundation of speed. Okay, so you might be wondering, what exactly is giving machines like Project ACE the sheer processing power to react instantly? Well, it all comes down to unprecedented infrastructure investments. $18 billion. That is Microsoft's commitment just to expand their Azure cloud and AI compute infrastructure in Australia alone. And that's on top of previous deals there from AWS and OpenAI. This massive capital injection is exactly what allows for the training of these incredibly complex models that eventually power our physical robots. And this investment wave, it's spreading like wildfire across the whole industry. SAP is pouring over $1 billion into a frontier AI lab just to master structured data. Tesla is literally taking silicon into its own hands, partnering with Intel on an unfinished 14A process to build a massive terafab chip-making facility to avoid future supply crunches. But hey, it's not just giant data centers, it's happening right in your pocket. Apple's M4 chips, Qualcomm's Snapdragon X Elite, Intel's Meteor Lake, they are all putting neural processing units, or NPUs, directly onto our personal devices. This edge AI means massive processing happens locally, zero lag. Section 2. Humanoids outpacing humanity, from the factory to the finish line. So if a stationary robotic arm can track a ping pong ball at 9,000 RPM, what happens when you put that exact same processing power into a fully mobile humanoid body? Well, check this out. At a recent half marathon in Beijing, over 100 humanoids actually raced alongside humans, and a Chinese-made robot named Lightning finished the race in 50 minutes and 26 seconds. That is nearly 7 minutes faster than the top human world record. Now sure, it wasn't a completely flawless victory. Lightning did crash into a railing right near the finish line and needed help getting up. But the sheer athletic output over a 13-mile run proves that robotic endurance and speed are officially crossing the human threshold. And the timeline here is moving astonishingly fast. In a single year, we've gone from Boston Dynamics debuting a fully electric, production-ready Atlas for industrial use to just months later, Unitree pushing out the G1, an acrobatic, highly dexterous humanoid starting at just $16,000. And then you've got 1X Technologies prepping the Neo Gamma for home integration. That is literally a consumer robot wrapped in a soft 3D printed nylon suit designed to safely move around your living room. We're transitioning from heavy industrial machinery to affordable, agile home companions in a matter of months. But it's not just about speed or doing backflips. It's deeply about resilience. Researchers are seeing that this hardware is literally learning to take a punch. Field tests of a humanoid called the T-800 show it's sustaining extreme physical damage. We're talking losing its head in fight videos, and it just keeps swinging. Engineers call this concept graceful degradation. The AI essentially adapts to its broken physical state and just keeps executing its mission. Section 3. Autonomous agents taking control. The death of the keyboard. Now, while physical robots are learning to navigate the real world, AI software is undergoing a parallel evolution that's just as crazy. We are moving way beyond those passive chatbots where you just sit and type a prompt. 2026 agentic AI is an active participant. These systems are reimagining how we use a computer. With gaze tracking and voice commands, you can literally just look at a screen, tell the AI to move a file or edit an image, and it takes over your mouse and executes the clicks and keystrokes for you. To put that into perspective, a 3D creator recently showed off what happens when they let an AI tool called Claude Code completely take over their Blender rendering software. The AI connected directly into the software's environment. The user just asked for a 3D angel character to be scattered into parts, dropped onto a floor, and animated in a tornado-like assembly. And the AI did the whole thing. It wrote the scripts, ran the physics simulations, and rendered the final 3D animation entirely on its own. This is a massive ecosystem upgrade. OpenAI's new GPT 5.5 is completely dominating agentic coding benchmarks. Microsoft's Copilot is now actively editing Word documents and building Excel spreadsheets without even needing to ask. NVIDIA is launching self-evolving desktop agents. We've even got AI like deep research that will go out on the web, read 30 different sources, cross-reference them all, and build a fully cited web page while you're off grabbing a coffee. Analysts are calling this the era of turning our digital capital assets into self-driving software endpoints. It's a total game changer.
Section 4. The Future of Mobility, Scaling AI to the Streets and Skies. Okay, so we've got lightning-fast edge chips, agile humanoids, and independent software agents running our computers. This naturally brings us to the final frontier, how we physically move through the real world. Autonomous mobility is breaking out of isolated testing grounds. Uber is officially pushing into Europe, launching their first commercial robotaxi service in Croatia. They're using Pony AI's autonomous tech integrated right into BAI's CR Fox vehicles. They're not just testing anymore, folks. They are scaling to thousands of units.
And we're seeing all kinds of wild new forms of transport emerging. Kawasaki revealed the Karo, basically a four-legged robotic motorcycle with adaptive hooves for off-roading. They're also building these Alice hydrogen pods that seamlessly dock onto trains or ferries while you just sit inside. We're even seeing autonomous pods gliding above city traffic on cable systems. Now, to be totally impartial here, it's not a flawless transition quite yet. We've seen reports out of central China where Baidu's self-driving robotaxis experienced system malfunctions and stalled out, causing massive traffic jams. So real-world infrastructure is definitely experiencing some growing pains. But those growing pains, they're just speed bumps on a very, very fast track. I want to leave you with this final thought as we wrap up this explainer. We started out looking at a robot tracking a 9,000 RPM ping pong ball. We've seen humanoids outpace marathon runners and desktop agents take complete control of our software. When all these interconnected, highly capable systems fully converge, when your smart home assistant talks to your robotaxi, which talks to your office humanoid, how will that fundamentally redefine what you spend your time doing tomorrow? Thanks for diving into this with me. Keep learning and stay curious.